I'm going to use that advanced theory to take you through some of the examples in the app. So we have here example of beam to column connection design for the custom steel bracket connection for a seated beam connection. So first example is if we're using only vertical screws or horizontal in this case. So how many screws we'll need and how this design would work. And the next thing I'll show you also with the incline part. So if we go back to the app, I'll show you what I pre-configured here. So we have some reaction forces, we have some configuration set up. So again, steel plate is in the same screw module set as the first member, GLT is for the second one. We have here configuration set up, so you can see how this works. But if we turn out here, we can see that 108 kilonewton is in the X direction setup. We can see also in 3D how this works. So I just practically taking the part of connection from the steel bracket to the timber column, and this is taken as internal column. So we have a height and width of column of 360 millimeters. Going further, so we have Eurocode 5 as a selection for member. I've chosen 8mm thickness steel plate. I pre-configure what we have for GLT, and for the fastener, I in this case selected throttle bus screws, HBS plate. So this is again filter out accordingly, and in this case I've pre-selected 10mm diameter and 120mm length. If we go and see what's happening with the standard arrangement configuration, so we have ability for select screws in both directions. I pre-configured here, so shear capacity is for this force, reaction force is below 100, so we have 96, almost 97%, but we're using a lot of screws. So we have here almost 20 or exactly 25 screws for this configuration. So this is something that is firstly a big number of screws for this connection, and secondly it's hard for installation as well because we have that amount of screws. All the calculation and information about detailed design is listed here according to steel to timber connection, and you can find more information on this in particular. But I'll jump back again quickly to the slide part and show you how we can utilize this. So here is just the idea that we can use the different configurations. So just use inclination in the part of timber column, and with inclination use the axial effect of the screws. So if we jump back again to the app and to check this example, for instance, so I use the same configuration in terms of the properties of timber, thickness of the steel plate, geometries, but I just enter or set up the inclination angle, and how you can do that. So anything from the inputs should be the same. Just on the part of the fastener data below the screws, you have option for inclination angles according to both the direction of planes. So we have alpha 90 degrees or alpha 0. In this case, for alpha 0, I set up 135 degrees angle, and that's something that will show up on the imagery, so you can see in what direction is force coming, and also in what directions are screws set up. So in this set of configuration, you can see how you have only verified the axial capacity of the screw and how this happens. So in this case, we have instead of 25 screws, we have 7 in one direction and 2 in other, so total 14 screws. In this case, we use fully threaded screws, so I set fully threaded VGS, and I set 9 diameter times 300 length. And in this case, so we are using less screws. We are using which is something that is optimized from the point of view of installation, but also how screws are being used in the best sense of their capacity.